Right now, we're inside a computer program.
Is it really so hard to believe?
Elegant experiments with entangled light have unveiled a shocking discovery at the heart of reality. Physics Nobel Prize winners prove that the universe is not locally real. But what does that mean exactly? Quote-unquote real means that objects have definite properties independent of observation. The moon, for example, is always in orbit around the Earth, even when no one is looking. Local means objects can only be influenced by their surroundings, and that any influence cannot travel faster than light. However, investigations at the frontiers of quantum physics have found that these things cannot both be true. This discovery has prompted some people to immediately connect the dots with the simulation hypothesis.
You know, there's this interesting argument by Nick Bostrom, and he argues that the notion of a simulated universe, that, the matrix, if you will. Imagine one day we have these powerful supercomputers, and we really, with fantastic fidelity, can create a universe in silico, if you will, which has sentient beings within it that don't know that they are in a simulation. And he goes through an interesting argument. Let me just simplify it. It's so, in principle, easy once you have that technology to create a simulated universe, that there'd be many more simulated universes than real universes. Real universes are hard to create. Maybe there's one, maybe there's a few, but it's hard to imagine that you could create them in as great abundance as you could create universes in a computer. You come home at night, you flick it on, you create a universe, and you sort of kick back and you watch what happens. So he argues that it's therefore much more likely, just based on the statistics, that we are in a simulated universe.
The simulation hypothesis proposes that all of our existence is a simulated reality. Philosopher Nick Bostrom explains how the simulation argument shows that 1 out of 3 possibilities must be correct.
A lot of people have proposed that as a possibility. The whole premise of the matrix or anything like that is that just as we can build simple virtual realities today with simple simulated creatures living inside them, maybe in the future with vastly more powerful computers you could build more complex virtual realities with more complex simulated creatures inside them. Maybe these creatures could be complex enough that they would actually have brains like ours simulated down to the level of individual neurons and synapses, such that the inhabitants of these simulations would be conscious. But what the simulation argument adds to that is that instead of just stopping at the question of how could you ever prove with certainty that we're not in a simulation ourselves, the simulation argument tries to establish a constraint about what we can believe, and it tries to show that 1 of 3 possibilities is true, although it doesn't tell us which one of them it is. Now, in a sense, this sounds more radical even perhaps than some of the multiverse theories. In another sense, it's less, because it doesn't presuppose any unknown physics. So we're just assuming that it will be possible to build computers that are much more powerful in the future. So what the simulation argument tries to show is that 1 of 3 possibilities is true. The first one is that almost all civilizations at our stage of technological development go extinct before they become technologically mature. Technologically mature meaning having developed all those technologies we can currently show are physically possible, given only uncontroversially obtainable physics. Big computers the size of planets and stuff, we can calculate what performance they would have. We can't build them now, but so first possibility is people at our stage, they just fail to get through to that level of technological maturity. Maybe they destroy themselves on the way. Second possibility is that almost all civilizations that do reach technological maturity lose interest in creating these kinds of ancestor simulations, as I call them. These would be detailed computer simulations of people like their historical predecessors. So they have these powerful computers, they have the ability to program them, but they have better things to do with their computers in their time. And the third possibility is that we are almost certainly living in a computer simulation. And the argument, in its full version, it requires some probability theory, but the gist of it can be grasped quite simply and intuitively. So if you imagine that the first 2 possibilities do not obtain, that means some non-negligible fraction of civilizations at our stage do reach technological maturity, and some non-negligible fraction of those, are interested in creating these ancestor simulations. They devote some non-trivial fraction of their resources to this end. You can then show that there would be many, many more ancestor simulations than there would be original courses of history. Because if you calculate the computing power that a technologically mature civilization would have, and the computing power that would be required to simulate all human brains. It turns out that the latter quantity is a tiny, tiny fraction of the former. So, in other words, by devoting a tiny fraction of their computational resources to this end, they could create astronomical numbers.
The trilemma of Nick Bostrom points out that a technologically mature post-human civilization would have enormous computing power. If even a tiny percentage of them were to run ancestor simulations, the total number of simulated ancestors, or sims of the universe, or multiverse if exists, would greatly exceed the total number of actual ancestors. Bostrom goes on to use a type of anthropic reasoning to claim that, if the third proposition is the one of those three that is true, and almost all people live in simulations, then humans are almost certainly living in a simulation. But how would a sufficiently advanced technological civilization create a simulation with the lives of billions of people that live in a seemingly infinite universe?
If you have the ability to use some advanced form of nanotechnology to transform planets into computational systems, by using just one planetary computer, just a millionth of its computing power for a tiny fraction of 1 second, you could run many, many courses of simulations of human history. If the first two are false, the first two assumptions, you then reach this conclusion that there would be many more simulations than originals. And if almost all people with our types of experiences were simulated rather than implemented in basic level reality, we should think that we are probably one of the typical people, the simulated ones, rather than the very exceptional ones that were part of the original history. Well, I believe the simulation argument which shows that one of those three is true, but it doesn't tell us which one. So I think we should distribute our credence over each of these three possibilities. We just don't have enough evidence to pick one. If we assume, for the sake of the argument, that it's the third possibility, the simulation hypothesis, that's true, then a lot of people's first reaction is, well, we might just as well go crazy, anything could happen. But once you start to reflect on it for a little while, you realize that even if we are in a simulation, the best way to predict what will happen next, to decide what to do, are still the methods that we would use anyway. We observe patterns in our simulated reality, we extrapolate them, and act accordingly.
The simulation hypothesis, or possibility number 3, that states we are almost certainly living in a simulation, has also many detractors who rightfully point out that the proponents of the simulation hypothesis have not, or possibly cannot provide evidence, if not proof, that we indeed live inside some sort of computer simulation. Although the fine-tuning argument has been used mostly by religious zealots to point out that the universe, including us, were made by a creator, now it seems some proponents of the simulation hypothesis like to use it as well. However, the multiverse hypothesis may provide a much simpler explanation for the fine-tuning of constants in the universe that allow life as we know it to exist.
One of the reasons for taking this type of model seriously is the fine-tuning problem. So we see that there are a number of these physical constants that appear to be fine-tuned for life. It's puzzling. Why should they have exactly the right values that enable, human beings or that enable any kind of complex chemistry at all? It could be just a coincidence, but by definition, it would be very unlikely that the values would just turn out right by chance. Of course, if you're religious, you could think that God designed it to be like this, but that explanation has all sorts of further problems that are well known. You could search for some further simple theory that nobody has thought of, some simple equation that is itself very simple, but from which all these specific values of the constants would just pop out. Problem is nobody has any idea for what that simple thing could be, and there is this big ensemble of universes, and the values of constants in these universes vary randomly. So that you have all or almost all possible different constellations of values of these constancies are implemented or instantiated in some universe or another. But most of these possible universes will be void of observers. The observers will only live in those universes where the values are exactly right for the evolution and existence of life, complex chemistry. So all observers will find themselves living in these universes where the values look like they are just fine-tuned, because they only see the universes where they are fine-tuned. All the others are void of observers, or at least there are much fewer observers.
Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.